Section 3, Data Models 2, Introduction. In this study section, you will learn about the different data models which are often responsible for the structure of database systems. Database management systems are eventually structured and modeled after these data models. You will also learn the evolution between these various data models and their individual characteristics which determine their ability to define data in that modeling. Learning outcomes. At the end of this study, you should be able to identify the various data models, explain highly structured database models. Evolution of data models. From our last study, you learned what a data model is and the concept of data modeling. You also learned the basic building blocks of data models for use in database design. In this study, you will examine the various types of data models available for database design. These data models are principally categorized based on their structure and their concept, logic of representing the data model building blocks. Table 3.1 below gives a summarized view of the data models you will discuss in this study arranged according to the order of their evolution. You've discussed the file system in study 1, so you just start our discussion from hierarchical data models. Hierarchical data model. The hierarchical model was developed in the 1960s to manage large amounts of data for manufacturing projects. The basic logical structure of the hierarchical model is represented by an upside-down tree. This hierarchical structure contains levels or segments. Each segment is analogous to a record type and there is a set of one-to-many relationships between segments. A typical example of the hierarchical data model is shown in Figure 3.1. Figure 3.1, Hierarchical Data Model. Employee to permanent to contract, permanent to manager to software engineer. Network Data Model. The network model was created to represent complex data relationships more effectively than the hierarchical model. Hence, it improves database performance by imposing a database standard. However, as shown in Figure 3.2, it is similar to the hierarchical model in its structure, but unlike the hierarchical model, a record may have more than one parent record. The network model is essentially a collection of records in one, M relationships with each set composed of two record types. An owner records, which is equivalent to the hierarchical model's parent record. A member records, which is equivalent to the hierarchical model's child record. Although the network model is no longer in use today, it defined some concepts which are still in use today in the database community. Some of these are schema, the conceptual organization of an entire database as viewed by the database administrator. Subschema, the database portion seen by application programs. Data management language, DML. This defines the environment in which data can be managed. Data definition language, DDL. This enables the administrator to define the schema components. Some of the reasons for the discontinued use of this model are the fact that it's cumbersome in structure and it lacks ad hoc query capabilities which placed burden on programmers to generate code for reports. The network model was also known to be prone to havocs in all application programs due to structural changes in the database. Figure 3.2, the network data model. The relational model was developed by E.F. Cord, IBM in 1970. The relational model represents entities as tables called relations. A table is basically a matrix consisting of row, column, intersections. Each row in a relation is called a tuple, representing an entity instance. Relational models were considered impractical in 1970 because the model was conceptually too simple at the expense of computer overhead. However, its conceptual simplicity set the stage for a database revolution. Figure 3.3 shows the structure of relational model as explained above. SQL-based relational database applications involve three parts. User interface, which allows end users to interact with the data. A set of tables stored in the database with each table being independent from another and the rows in different tables being related based on common values in common attributes. An SQL engine which executes all queries. Entity Relationship (ER) Model. The Entity Relationship Model, introduced by Ken in 1976, was widely accepted standard for data modeling. Entity Relationship Diagram (ERD) uses graphical representations to model database components. An entity is mapped to a relational table. An entity instance or occurrence corresponds to a role tuple in a relational table. An entity set is a collection of similar entities. The connectivity in a relationship indicates the type of the relationship. ERD have two basic notations shown in figure 3.4 below: the Ken notation and the crow's foot notation. In Ken notation, entities are represented by a rectangle with their attributes in ovals around them. Relationships are represented by a diamond with the relationship name written in the diamond. Crow's foot notation. Entities are represented by a rectangle with their attributes listed within the rectangle. Relationships are represented by a straight line which could be dashed or solid depending on the participation constraints. The name of the relationship is written on the line. Relationship types are usually by the type of symbol at the end of the relationship lines as shown in figure 3.4. A conceptual model, full database model, is shown in figure 3.5 for your understanding. Figure 3.4, ERD Ken and crow's foot notation external model. Crow's foot notation. Ken notation. Figure 3.5, ERD crow's foot and Ken notation conceptual model. Object-oriented model. In the object-oriented data model, data and relationships are contained in a single structure known as an object. OODM, Object-Oriented Data Model, is the basis for OODBMS. An object contains operations, is self-contained, and is an abstraction of a real-world entity. Attributes describe the properties of an object. Objects that share similar characteristics are grouped in classes, and classes are organized in a class hierarchy. Objects inherit methods and attributes of their parent class. UML based on OO concept that describe diagrams and symbols is used to graphically model a system. Object 1, Maintenance Report, date, activity code, route number, daily production, equipment hours, labor hours. Object 1, Instance 01 12 01 24 1.95 2.5 6.0 6.0. Object 2, Maintenance Activity, activity code, activity name, production unit, average daily production rate. Figure 3.6, Object-oriented model showing two objects and an instance, the first object. Modern data models. Here you will discuss some newer data models which are increasingly being used in modern DBMS. The Extended Relational Data Model (ERDM) is a semantic data model developed in response to increasing complexity of applications. It includes many of object-oriented models' best features and is often described as an Object Relational Database Management System (RDBMS). It is primarily geared towards business applications. It is in this environment that Extensible Markup Language (XML) emerged as the de facto standard for the efficient and effective exchange of structured, semi-structured, and unstructured data. In order to manage the large amounts of data generated in this complex format, XML databases emerged to manage unstructured data within a native XML format. Figure 3.7 shows a chart explaining the evolution of the data models discussed so far and their specific semantics characteristics each. Figure 3.7, Evolution of data models showing their semantic properties. Semantics in data model. Least to most. Comment. Hierarchical. Difficult to represent M such N relationships hierarchical only. Structural level dependence. No other queries record at a time access. Access path predefined navigational access. Network. Relational. Conceptual simplicity, structural independence provides ad hoc queries, SQL, set-oriented access, entity relationship, easy to understand, more semantics, limited to conceptual modeling, no implementation component. Semantic to object-oriented to extended relational ORDBMS. More semantics in data model, support for complex object inheritance, class hierarchy behavior, unstructured data, XML data exchanges. Highly structured database models. For many decades, business applications for computers involved underlying database systems. Each of these systems tended to have its own model for the data. In this context, a data model is an unambiguous and neutral view of data that consists of a set of concepts used to organize the data describing its structure, so it is comprehensible to the computer applications programs. Traditionally, these data models have been studied in database research and development, where two main classes of data models are distinguished: object-oriented and record-oriented models. In addition, there exist different abstraction levels at which data models can be introduced: the interoperability application level, the conceptual logical level, and the physical level. These three levels of data abstraction make it possible to achieve both logical and physical data independence. Standard data models for databases are entity relationship model, conceptual model, relational model, record-based model, SQL standard logical models, network and hierarchical model, legacy models, physical models, object-oriented models, e.g. ODMG's object model. The WWW semi-structured data model. The advent of the World Wide Web introduced a world of data and information that was not organized according to such precise and formal mechanisms. While the traditional data models are useful in dealing with structured data, e.g., data organized in formal databases, they are not as successful for representing the semi-structured data, SSD, of the sort that is found on the web. The SSD web data has the following characteristics. Ramakrishna. It cannot be represented completely by formal schemas or types. It generally has an irregular structure and is heterogeneous and deeply nested. Its structure evolves often without notice. It can only be accessed through limited capabilities. It has links among datasets stored on distributed servers. As the success of the web has shown, SSD provides a convenient and flexible format for exchanging and querying data and information. Moreover, SSD arises in important application domains such as scientific data collections and digital libraries, where there is a strong demand for information and data integration in spite of the fact that the underlying data are not formally structured along the lines of the traditional database models. In the language of computer science, the data model of the web's SSD consists in a rooted, edge-labeled, directed graph, e.g. OEM, UNQL. In layman's terms, this describes the connections established by the pointers among the many documents on the web. In the example of the boulder map in the figure above, the various features specified in the legend are in fact stored in a relational database, and the map is generated by the Geography Network Explorer, which transforms the features into layers in a form viewable within a web browser. Specifying a structure for data accessed via web services, while the specific modeling of data using formal database schemas is powerful in the context of targeted database computer applications, a more general form of data modeling, independent of specific applications, technologies, is needed to facilitate integration and interoperability among data sets and computer applications that access and use them in the context of the web. Summary. As we conclude this study sessions 3, you are expected to have learned that the evolution of the different data models and their semantic properties in defining data within a data model, as you can see, The data models have been evolving over the years by improving over existing ones. So far, the AR model is preferred for data modeling in database design and will be adopted in our teaching of data modeling in study section 5 and 6. The relational model is widely employed in most commercial DBMS, and the more complex models are extended versions of it. Therefore, you will first learn some basic concepts of this data model in the next study. This is the end of study section 3. Thanks for listening.